It's great to be here, see everyone from ROS. This is actually my first ROSCon, so yeah, it's good to see such a large group of people. This talk was called From the Internet of Fields to the Internet of Plants, but actually I think it should be more called What You Can Do with ROS plus OpenCV in less than 6 months. So you'll see that as this presentation goes on. And what's critical here is that you can prototype robots and other parts of your system really quickly and then test them with customers and pivot if you need to. And traditionally this might have taken many years before, but now you can do it very quickly. So what's Deepfield? Deepfield's part of the Bosch startup platform. So this is a number of companies, much more nimble. We are sort of 100% owned by Bosch, but work with very separate processes, network, talk a lot to customers, maybe every second week out with farmers for us, talking with them, trying to find out what they want. And not just what they want, but what they're willing to pay for, which is quite a different thing. So, many people here in a startup would have had that conversation where you spend, say, an hour talking to a customer. It's really great. They're saying, that's interesting, that's interesting, that's interesting. You ask them, how much would you pay for it? Oh, we wouldn't pay for it. So, that's the sort of conversation that we have a lot. So what we're really about is sustainable agriculture. If you look at what's happened in the past with agriculture, it's all been about increasing the productivity of the farmer. Larger, heavier, faster tractors, all about increasing, his productivity. I really believe that robotics is going to help with this and bring back productivity to the field and sort of give each plant the tender loving care it needs so that it can, get as much yield as possible out of it to help feed, a growing population. So Deepfield has two main parts. One is an IoT connected part. This is part of Bosch's IoT cloud solution. So these are sensor networks, really important, helping detect, say, frost damage on fields before it happens. It can really save quite a lot of produce. The other part, which is the main part of this talk, is about robotics and the robot platforms that we've developed. So before going on to Deepfield, Bosch has a number of divisions. Some of these are startups, some of these are part of corporate research, others are part of the engineering. Deepfield, there's also Mayfield, the personal and service robotics. Expect to hear more about them next year. We've got our warehouse and logistics type robot systems. So these are Xenoway for localizing within factories and Autobod for moving parts around within warehouses. And then indoors, sort of more in the commercial side, intelligent transport assistants. There's also research projects, many of these, there are probably heaps more than are listed here. Collaborative robotics technologies as well as SLAM. And then, of course, many autonomous car groups. A lot of Bosch's business is cars. So, we're in that space as well as sensor networks. What's common about all these? They all use ROS. Hopefully this is the most number of ROS logos on a slide. I win that award for that. But yeah, ROS is certainly throughout a lot of Bosch and has a history in Bosch. So Deepfield, on the robotics side, three main platforms. So on the left is the Weedmobile. So this is a robot for managing weeds. It uses our pattern stamping tool to basically smash weeds into the ground. This is ongoing development to do this. In the middle is the Bonnie-Rob. I'll talk more about that in the next slide. And on the right is our Phenomobile, and that's the main topic of this talk. So the Bonnie-Rob is the robot that most people would know and recognize. Sometimes you see it in green, an earlier version of it. It's basically a multi-purpose autonomous tractor, so you can build various implements for this. It has sensors on it to detect obstacles. It has 12 motors, so it can change its width so it can navigate down track rows. It's been ROS since version 2, which has really helped. We've sold 2 of these to research partners, and having the ROS system has enabled us to collaborate with them much more easily and expose the interfaces that we want for them. Expect to see some more about this. There's some ongoing work about collaboration with Bonnie-Rob, the robot here, as well as with UAVs for scouting and things like that. So, plant breeding. This is really important. It's been one of the primary reasons that we've been able to increase the yield of crop. So new varieties are tested in the lab, and then over about 10 years from when they're developed in the lab, they're put out into fields and constantly tested and working out, which ones actually work. And so this is important to test for, say, disease resistance, as well as, the actual yield they're going to get, and, making sure they work in each particular region. And there's many tens of thousands of these plots spread over, large geographical areas, and each plot has hundreds of plants in it. And what you can see in the photo is really state-of-the-art in terms of monitoring these fields. So people go out and they count the plants, or they'll pick a few of them out and cut them up, or they'll look for diseases, and they're basically selecting which trials go on, which varieties go on, and which don't. And as you can imagine, this is quite tedious work. Lots of people need to do this, and it's ambiguous. So you have multiple people doing it over multiple regions, multiple cultural sort of interpretations, and yeah, it's not necessarily consistent. There's been, as well, after this, you generate a lot of paperwork. And state-of-the-art for this is putting it into an Excel spreadsheet and then, merging it later. And, that sort of is probably not the best practice. So there's a variety of solutions for this, from satellite imagery through to fixed-wing aircraft, multi-rotor aircraft, platforms on the field, as well as in the lab, moving the plants around on conveyor belts. So Deep Field Solution is a semi-autonomous platform. We're working with our pilot customer Struber on this. So this robot is diesel powered. It's about 2 meters wide. When I say semi-autonomous, I mean a person still drives it onto the field, but for each plot it drives by itself, because it's actually more accurate than the person when it's driving by itself. So we have some cameras, and I'll talk a bit more about them in a sec, measuring the plants. And so what we're interested in measuring, though, is counting the total number of plants that have emerged, as well as ones that have died, measuring the size of the plant, so the height, the colour of them, as well as the canopy. And by canopy, sort of mean leaf area. So in the 2D sense, so when the plant's quite small, you can measure the plant area with a 2D measurement, but as it gets larger, you need to measure it in 3D, so you can get an accurate measure of the plant. Having a little bit more into the robot and seeing what it's seeing. So we have two cameras, a 2D camera. So one of these is a GI camera. This is RGB IR camera for measuring the plants, and we do this at the early stage. And then in a later stage, we use a 3D camera, the Connect 2, to get the 3D structure of the plants. So for this particular study that you saw there, over 40 days, we recorded plants 17 times. So in the early stages with the 2D measurement, and in the later stage with the 3D measurement. Getting a little bit deeper into the technical details of the platform. Most of this robot is best practice for robot design. We have safety PLC, heartbeats between different parts of the system, diagnostic nodes. So our lowest level of our drive control is the drive ECU. I'll talk more about that on the next slide. We also have our control and coordination where our ROS master runs. This talks to various relays, as well as our control and diagnostics tablet for monitoring its performance. And then this also talks to our camera app. So we have 3 of these recording at one time. One important thing is that at the end of each trial, we run a sanity check on the data to make sure that it's okay, so that the correct velocities were maintained, as well as, say, with the camera, that you didn't forget to take the lens cap off, as many of us I'm sure have done. So we have this robot. It's in the middle of the field. We've got hundreds of gigabytes of data recorded onto it. We need to get that back to deep field, so we don't take 3¼ inch floppies. It is actually SSDs that we take from the robot back to our bag bunker, which we'll talk about a little bit more in a second. So We take these to what we call upload bay, which is connected to bag bunker. These enable us to load it into the system. When bag bunker has run a sanity check on it and we know that this data has been properly uploaded, a file is written to the SSD so that when it's taken back to the robot knows that it's finally okay to delete the bag files from its own computers. And over the course of 2 months, we recorded about 24 terabytes of data, and we didn't lose any data in this process. So it was quite a reliable system. So now we've got all this data in our system, then we run our pipeline on the bag files to find all the plants and get these ready for display on our website. So to process through the 24 terabytes, I think it's about 2 million plants, and it takes us about 3 days to run through all this. So the drive ECU. One of the requirements for this was it had to be absolutely real time, and this monitoring of interrupts. Lots of discussion in deep field. Many people more towards let's go the really embedded controller, proper RTOS type system, all the way through to let's just get it working, throw lots of hardware at it, make sure hope that it doesn't have any problems. The solution at deep field was to use an Odroid with the preamp patch. Now obviously you trade throughput, but that's not such a big problem when you're just running more motor control loops for it. The question is, how reliable is it, and is it really real time? The OS ADL runs racks with these machines, and one of them is Odroids. So over a year, they've been running performance tests on it, obviously you want to check that things don't crash and all of that, but one of the key things you're after is unsatisfying worst case latency. And so in this diagram, you can see that with many, many tests, it's maintained no outliers in latency. So that gives us some confidence that this is a good platform and kernel to use. So lifecycle management's really important. It's coming in ROS 2.0, which is great to see. We needed it a little bit earlier, so we ported it back into ROS1. I'm sure many of us have had the problem where we've got launch files with number of nodes and we need to get them all started up and synced properly and ordered. And I'm sure many of us have done the hack where we wait for something to publish before we start the next node started up. Lifecycle helps with this, but that's not the only reason for it. It's really to help give explicit visibility of the operational state of each of the nodes so that you can really tell what state they're in and bring them up and down in a defined and explicit manner. We use this at the moment for controlling our cameras and our lighting system so that we know what state that they're in. And there's going to be a release open source of this soon. We also have control and diagnostics display. So, there is already systems in ROS for monitoring, ROS out or RViz. We needed a custom solution for this. So you can see the green triangle, which is our robot driving along. The rectangle is the plots. And you can see the robot driving along as it gets to the end. Once it's run the sanity check, it now knows that trial has been successfully recorded, and we can go on to the next one. So in the bottom left, you can see the camera images. You can click on these and get bigger pictures of them, both in RGB and the IR imagery, so that you can check what the robot is seeing. At the top, you can see a little green bar. So this is basically the proportional error. So early on, people were actually driving the robots. This would help give them the control input that they needed on the joystick of where to drive the robot, but eventually this was connected through to the robot so that it could do it autonomously. In the bottom left corner as well, when the robot starts to move along here, you'll see some of the monitoring, the diagnostics, and this is a little bit picture showing the state of the robot. So for example, if the CPU speed gets too high, it'll alert the user so that we know in real time that these problems are happening. So bag bunker. On many projects, I've always wished to be able to look up that bag file that I recorded 2 years ago. I knew it was some date, roughly the location. That's what bag bunker helps you to do. You can search for bag files within your storage system. And not only that, it also can run scripts on it, so to do, as I said before, sanity checking to make sure that they're okay, as well as produce, say, imagery or plots. I won't talk much more about that because this is the focus of the next talk, and Dion will be talking about that and explaining this. We've released this open source, and yeah, Dion will talk about that more. So now we have all our data in BagBunker. We want to actually process it. So we recorded over 17 days, and we need to register the plants over those days so that we get the same plant in the same location. So the first part is this is classification. So we use a random forest tree to classify. This gives us a pretty good accuracy, about 90% on a per frame basis. But once we register the images, so we use GPS locations for each plant, and once we register these over multiple days, we get really, really high accuracy. It's much easier to detect the plants later on. One of the specifications for this is that we would detect emergence of plants down to 0.1 centimetres squared. So at that size, it's a little bit hard to classify, but later on, it becomes much easier. So on the side, you can see the original classification or the previous classification, green meaning a sugar beet and red meaning a weed. And as it goes through, some of these will change colour because of later information has given us more information to give a better class to the plant. So we also have so once we have this data processed, we upload it to a website so our customers can view it. They don't all use ROS. So this is our deep field cloud site. You can select the particular series of plot that you want to have a look at. And so in here, you can see an image on the side showing the plot location. So a number of varieties of plant, of sugar beet in this case, were tested and against potentially different herbicides or whatnot. So from here, you can have a look at the average leaf area over time as it grew, as well as the emergence of the plants over time as they were detected. If you need more detail than that, you can go and click on a particular variety and combination of applicator on it, and then get more detail. So you can see the emergence rates, as well as mortality, how many plants died, and the leaf area for that, as well as see a histogram of that leaf area. Again, if you need more detail about one particular plot, you can go in and have a look at the stitched imagery for that, and then see the individual plants. So green is a sugar beet, and the orange is a weed that's detected. For each of those, you can go in and click on each one and have a better look at the plant, as well as some statistics on it. If you need more detail, you can go into the detailed view, and in here you can see each image that has been registered across time for that particular plant. So you can scroll through each of these individual plants, and then if you want to see the 3D imagery, you can go and zoom in and have a detailed look at the particular plant that you want. Okay, so future for us. Focusing on the technical side, love ROS 2.0, what's coming up. This is going to be really good. There's platforms that are being developed where we do it in ROS and then you have to rewrite everything eventually. So hopefully ROS 2.0 can help us with this in getting commercial products out much faster. Offline processing. So the second part is processing our bag files offline. And ROS is great in terms of the online processing and the message, but we really do need deterministic processing of this for it. And in particular, handling the node startup clock type problem. Obviously, you could just rewrite the whole thing to just be no ROS at the end, but we want to keep so then we can move it online or offline as need be. So we need some solutions for this that we'll work on. As been spoken about this morning, you can never have enough testing. If you're planning to develop a robot system, at least allow half the time for testing and building tools, at least half the time. And despite having some unit tests, the Docker build system, and all these other code review and everything else, still need more testing. And I think we'll have to end up with scraping websites and trying to check these against our original bag files. So we'll need to work on that. And accurate timing of sensors. For me, I separate cameras that are designed for computer vision versus sensors that are designed for robots, whether they have a trigger line and you can synchronize other parts of your robot to it, All too often we just put ROS time now when we receive the message. Unfortunately, that's not exactly the time that the actual data was collected by the sensor. So I'd love to see this a little bit more embedded into ROS. So hopefully this has shown a little bit about what ROS plus OpenCV can enable you to do very quickly, build an autonomous platform as well as pipeline, which really helps if you want to test something rapidly with customers. So the Deep Field team, you can see some of our alumni who have worked with us in the past. Tenaris, if you want a great website, great web tech, talk to them. They've been really, really good, as well as support from our Bosch corporate team. Thank you. And Dion's here as well, who might be able to help answer some questions as well.
Talked a bit about technical next steps, but I'd love to hear your thoughts about how do you go from sort of demonstration of concept to a business where you're selling lots of units for lots of money?
Yeah, that's really hard, particularly in agriculture. Particularly in agriculture, that's really hard. There's lots of different customers with different needs, and even the same crop is not grown the same way in different locations. So it is hard to do that. We just spend a lot of time talking to customers. One of the things you can't do though is just turn up to a farmer and just talk about an idea and expect them to be able to evaluate the worth of it. That's one reason. I mean, you might say we should have just not built this at all and just totally focused on talking to customers, but you really need something to show them what you're talking about. And a lot of the time you don't get your foot in the door to talk to them until you've shown that you're willing to do something yourself and build it. So yeah, still working on that. Yep.
Actually, let's go on the left first. Go ahead.
Yeah, so this is also on a slightly higher level. You also are running process and optimization in terms of the part of the robot days to actually examine the blinds, for instance. So is there any plans about you making something like a plugin for these kind of non-blind?
Okay, so I described it as semi-autonomous for the drive. So a person still drives the robot onto the field, and then just along the plot, which is a straight line, the robot is autonomous in that. So it's actually a fairly simple controller for that.
All right, so I heard about some agricultural robots before. So do you consider providing a service where you come to the field with a robot, or renting a robot instead of selling machines, which is difficult for some people to accept and buy for a full price?
Yeah, absolutely. Farmers are used to both models, so sometimes they'll buy very expensive machinery and sometimes they will just take the service. So they're used to both types of business cases, and certainly exploring both is part of what we'll do. Yeah, absolutely.
Thank you.